All right, so yesterday was not great, but today is going to be great. Um, Yesterday, it turns out there was a very simple O of n solution, which I did not come up with. I came up with this O of n squared solution, which is why my solution took so long. But today, we're not going to do that, and today we are going to um, today we're going to do a good job. So let's check this out. Chronal coordinates. Okay, so let's go over and make my file day 06 chronal coordinates.py. Okay, perfect. And the device on your wrist beeps several times. Once again, you feel like you're falling. Situation critical, the device announces. Destination interminate chronal blah blah blah. Produce a list of coordinates puzzle input. Are they places it thinks are safe or dangerous, or events you check manual page 729? They do not give you a manual. They're dangerous. Maybe you can minimize the danger by finding the coordinate that gives the largest distance from the other points. Using only the Manhattan distance, determine the area around each coordinate by counting the number of integer xy locations that are closest to that coordinate and aren't tied in distance to any other coordinate. You'll also find the size of the largest area that isn't infinite. For example, consider the following list of coordinates. If we name these coordinates A through F, we can draw them on a grid, putting 0, 0 at the top left. This view is partial. The actual grid extends infinitely in all directions. Using the Manhattan distance, each location's closest coordinate can be determined, shown here in lowercase. Okay, locations shown as dot are equally far from two or more coordinates, and so they don't count as being closest to any. For example, the areas of A, B, C, and F are infinite. While not shown here, the areas extend forever outside the visible grid. However, the areas of coordinates D and E are finite. D is closest to 9 locations, and E is closest to 17, both including the coordinates location itself. Therefore, in this example, the size of the largest area is 17. What is the size of the largest area that isn't infinite? And we get your puzzle input. Let's see what this looks like. So let's copy this and do day06.py. And this seems like it's not going to be a trivial problem. So we will need to think about it. So I have this grid, and basically A is on the outside, so it's going to be infinite. B is on the outside, so it's going to be infinite. F is on the outside, so it's going to be infinite. C is on the outside, so it's going to be infinite. So what I'd like to say, and let me think about if this is true, is that if I sort of say, given all my coordinates, what is the smallest x, what is the biggest x, what is the smallest y, what is the biggest y, then anything that lies on those lines is going to, and so my thinking is, and this is potentially wrong, is that if I had something like, let's say, here, which was inside C and F, then once I go far enough out, one of those two is going to be closer, but that's not, I don't think that's the case. Another possibility is to say that anyone who's on the boundary, let's say, if this guy is closest to F, then going further out is going to be closest to F, and so I think that's right. So really what I need to do is, so let's start with this input, and I'll think through what I just said. And so let's say raw is this, and let's split on new line, so then I'll call that line. Yeah, that's fine. Raw is that, and then lines is raw dot split n, and then and let's just get the points. and we'll take a lot. Let's do point from a line, which is a string, and that's going to be just a tuple of. Let's do the usual from typing import named tuple class point named tuple x is an int and y is an int, and we want to using the Manhattan distance, and so let's say def Manhattan distance self and other, which is a point, and that will give us an int, and so that is abs of self.x minus other.x plus, so Manhattan distance is just distance in the x direction plus distance in the right y direction minus other.y. So I think that's fine. And now to turn a line into a point, and let's just do this up here as well. Static method from line string, and that's going to return us a point, and let's say x, y equals line dot split on comma space, and then we want to return the point of int x, int y. Okay, so now we can do that, and we can say points equals point dot from line for line and lines. Okay, so let's just run that and make sure it works. IPython run day 06. Name point is not defined. So I guess I need to do this. Name lines is not defined. Okay, so I need to do this, and okay, so all right, and then points. So good. Okay, so here's what I want to do. Let me think about this. Okay. So I want to make a grid which will take, let's say, closest, which will take in some points, which is a list of points, and is going to return a list of strings. Actually, let's make this a list of ints, and we'll just have this be the index of each of the points. So that'll be fine. And so what I want to do, and do I have list done? So here's my idea, is that I'll say min x equals min point dot x for point in points, max x equals max point dot x for point in points, min y equals min point dot y for point in points, and max y equals max point dot y for point in points. And so now what I want to do is I want to say grid equals say grid equals none for blank in range. Actually, you know what? Let's just do this, and let's just say for x in range min x max x plus 1. So we want to include those, and we'll say for y in range min y max y plus 1 again. And so now we'll say, point equals point xy. Distances equals let's say this equals, so let's do this. Distances equals this dot Manhattan distance from point comma I for I point in enumerate points. So I'm just going to go through every other point. I'm just going to go through each of my list of points, sorry, and figure out the distance. And then I want to sort, and it will sort by distance from lowest to smallest. And so if distance is 0, 0, which is the distance of the closest point, equals distances 1, 0. So, two closest points are equally close. We'll say that grid of xy equals none. Otherwise, we'll say that grid xy is going to be distances 0, 1, which is the index of the first one. And so let's say return grid, and then print closest of points. And this might not be meaningful. Key error. Because I put double equals instead of single equals. So let's run this, and this is saying, this is hard to make a lot of sense, but 0, 0, 0, 0, 0, none, 1, 1, 1, 1, 1, 1. So I think that corresponds to something like 0, 0, 0. So anyway, and let's say largest finite area, and let's take a grid which is a dict of a tuple of, so you know what, let's do, this will probably be easier. And so this is not this at all. This is actually a dict from points to ints, and that means we need dict. So that's fine. And grid is a dict from points to ints, and I'm going to return an int. So again, I have to do something like min x equals min of point dot x for point in grid. Max x equals max of point dot x for point in grid, and then min y equals min of point dot y for point in grid, and then max y equals max of point dot y for point in grid. And then what I want to do is I want to say for points index in grid, and so let's say boundary indexes is a set. So that'll be, so what I'm going to do for point index in grid, if point dot x is max x or max y, point x is min x or max x, or point dot y is min y or max y, then we want to say boundary indexes dot add that index. Okay, so if we go around and we find a guy in the boundary and he's number 3, we'll say 3 is on the boundary, so he can't count, basically. And again, I'm not 100% sold on this idea. Here, it turns out to be true, because if I'm not on the boundary, then there's guys to my left and to my right, and so if I go far enough up, then eventually, so let me, oh, I wish I had a spreadsheet, but I don't have a spreadsheet. So let me, let me go just draw something over here, just to play around with this a little bit. So like, imagine I have A and I have B, right? And let me do B. So, you know, here I'm closest to A, distance 1 from A, distance 2 from A, distance 3 from A, distance 4 from A, here distance 1 from B, 2 from B, 3 from B, 4 from B, and 5 from A. So we go like this, and you know, B, 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 and this will also be a B, and this will also be an A, and then probably be a B, and this will be an A, and so on and so forth. And so now let's say I had like, let's say I had a C right here, because this is the case I'm worried about, is that going oh, well, that'll probably be okay, because there will be someone on the boundary who has him. So I think we're okay. I'm gonna not worry about that for now, and just go back here. And so I've taken all the guys on the boundary, and let's print boundary indexes, and then I want to find the largest finite area. So let's say areas equals counter. So I need a counter from collections import counter, and 4 point index in grid. If index not in boundary indexes, I'm not going to print this, I'll just print the areas. Then areas index plus equals 1, and then return, let's say, areas. So then let's print the areas for the closest. Why don't I just say grid equals closest for points, and print the areas for that grid. And let's run it, and it says that I am missing a colon, so areas is not defined, because that's largest. Well, actually, let me just do areas. Int object has no attribute x in grid.items. So let's run that. So this says that 3 has 8, 4 has 8, 6 has 8, 7 has 8, and 9 has 8. So that seems extremely wrong, especially given that 1, 2, 3, 4, 5, 6. There's only 6 points. Okay, so that's fine, actually. Those look totally reasonable. So let's see what I did. So min x equals min of point x for point in grid. Max x equals that. For point index in grid items, if point x is in max, add that to boundary index this, that's fine. So for point index in grid, again, dot items. So let's try this again. And now this says 4, 17, 3, 9. So E is closest to 17, which is right, and D is closest to 9. Okay, so that does the right thing here. And so what I really need to do is convince myself that my logic, where if something is on the outside, it's part of an infinite area. If something's not on the outside, it's not part of an infinite area. So let's think about this. F is on the outside here, which means that to get here from anywhere in this square, F is the closest. So if I go down 1, I'm 1 further from F, and I'm 1 further from everyone else. So F still has to be the closest. So that says that if I'm on the boundary, I've got to be infinite. And so now let's say if I'm not on the boundary, I'm not infinite. And so basically, the idea is that if I take one step out to the boundary, basically I'm 1 further from everybody. And so if I wasn't closest to somebody there, then I'm not closest to somebody in the previous one. So I think I agree with this. So now what we need to do is we need to say with, so I think I agree with my reasoning, with open data.day06.text as F, lines equals line.strip for line in F, points equals point dot from line line for line in lines. So let's run this and see what points is. And so I have a bunch. And now, this is 200 by 200, which is, I don't know, 10,000, 20,000. That shouldn't take too long to run. So now what I want to do is I want to say, again, grid equals closest. These are terrible names, but that's fine. And I want to say areas equals I'll call this count areas. That way, areas equals count areas of grid, and then print areas and print areas dot most common one. Okay, so let's go and run this. And I said it was going to take a while, but it took a while. So 27, 4011. So let's go and try that. What is the size of the largest area that's not infinite? So this is saying that I think 27 is the ID of it, and the count is 4011. So let's submit that. That is the right answer. So we're 1 gold star closer to fixing the time. Got ranked 211. Wow, so that's pretty good. 211th on the stars leaderboard. Continue to part 2. On the other hand, if the coordinates are safe, maybe the best you can do is try to find a region near as many coordinates as possible. For example, suppose you want the sum to all the coordinates to be less than 32. For each location, add up the distances all given coordinates. If the total is less than 32, that location is within the desired region. Using the same coordinates as above, the resulting region looks like this. In particular, consider the highlighted, hold on. Suppose you want the sum to all the coordinates to be less than 32. For each location, add up the distances to all of the given coordinates. If the total of these distances is less than 32, locations within the desired region. Using the same coordinates as above, the resulting region looks like this. In particular, consider the highlighted location 4, 3, where 4, I don't know how they call that 4, 3. Is that 0, 1, 2, 3, 4, 0, 1, 2, 3? Sure. Its calculation is as follows. Distance to coordinate A is 5, blah, 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 is 30. It's within the region. Its region also coordinates D and E has a total size of 16. Your actual region will need to be much larger than this example, though, instead including all locations with a total distance of less than 10,000. What is the size of the region containing all locations which have a total distance to all given coordinates of less than 10,000? Okay, so we could certainly brute force this, but that would take, well, so how many points are there? There's 50 points, right? So, and what's 10,000 divided by 50 is 200. So what that means is that, let's say I have a grid right here that has 50 points in it. If I am 200 off to its left, then I'm definitely, so like if I'm on the last row, my total points is more than 0, and if I go 200 off to the left, it's 10,000. So certainly, if I go 200, 200, 200, 200, which is going to be a somewhat big grid, but that's fine. So let's try that and see how long it takes. So now, so let's go up and add a method to here, which I'll say total Manhattan distance self. Others is a list of points. Int, and this is just return sum of self dot Manhattan distance point for point in others. Okay, and now what I want to do is I want to say, given a grid, find how many points are within some distance, some total distance. So count points within, and so we'll start with a grid again. Is grid what I want? No, a grid is not what I want. So I would just want to start with some points. So let's do points, which is a list of points, and then total distance, which is a int, and I'll say count squares within, and that will return an int. So we're just going to, so again, we're going to say min x equals min point dot, I should write a function for this, for point in points, max x equals max point dot x for point in points, min y equals min point dot y for point in points. And it's possible that this is going to be too slow, and so if it is, we'll think about it more, but we'll try the brute force way first and see if it works. So min and max, so again, and what I said was that I need to go an extra total distance divided by num points off to the side. So I'll just call that delta equals total distance divided by num points. And so now what I want to do is I want to say count equals 0, and I can do this in one line, but I would like to print some logging when I do it on the big one to see how fast it's going. So I can say for x in range min x minus delta max x plus delta plus 1, for y in range min y minus delta max y plus delta plus 1, total if point xy dot total Manhattan distance points is this less than or equal? Is it less than or less than or equal to? Less than. So is less than total distance. Count plus equals 1. Return count. And now let's print count squares within points and 32. So let's go here and run this thing, and num points is not defined. That is true. Len points, and that took a long time because it was doing that, so let's comment that out so it doesn't do it. And that says 16, and it has a total size of 16. So that seems correct. And so now what I want to do is print count squares within now the real points at a distance of less than 10,000. And now what I would like to do is couple things. One, print min x max x min y max y. Actually, so I want to, I'll just print that here. So print min x minus delta x max x plus delta. So this will give me a sense of how fast things are going. So let me just try it again with this guy and just see what happens. I run it and it's saying I'm going from -4 up to 13. Bam, I'm done 16. Okay, good. So let's comment that out and we'll do this. And this will just, oh, this is not too bad at all. So this just needs to run up to 546. And so I won't worry about making it faster because it's pretty fast. It says 46,054. So let's try it and see if that's right. Less than 10,000. And so I think I did less than 10,000. I did. So let's do that and submit it. And that's not the right answer. Please wait 1 minute before trying again. So you guessed that. So let's so let's say TMD equals point xy total Manhattan distance points. Print xy TMD. So let's not do that. And then if TMD is less than total distance, count plus equals 1. Okay, so let's run this again and actually, let's just print the ones that look like this. Okay, so let's peek at a couple of these. So let's say point of 312, 232 dot total Manhattan distance of points 999. So that seems right. And so let's do so if I sum those up, that's again 99.95, which seems pretty good. So 4 point in points, print point point dot Manhattan distance of that guy. So I have 312 to 232. So let's find 312 to 232. So that's 3 here and 2 here is 5. So I think that's right. So let me print min x max x min y max y, and then return, because that's just all I want to see. 40 to 346, 53 to 351. So let me do one more thing, which is that rather than counting, let's say squares is a set, and let's say squares dot add point xy, and return squares. And let's just print x, and squares equals count squares within, and let's run this and figure out what we did wrong. Okay, so min s dot x for s in squares, min s dot y for s in squares, max of s dot x for s in squares, max of s dot y for s in squares, and now min of p dot x for p in points, 40, so that's fine. Min of p dot y for p in points, 53, that's also fine. Max of p dot x for p in points is 346. And max of p dot y for p in points is 351. So these are all outside of basically 20. So did I make a math mistake somewhere? Message retracted. That's good. So I have 50 points, and 50, 10,000 divided by 50 is, like I said, 200. So let's think about why this wouldn't work. Did I 46054. Okay, so I have my points, and I have a total distance, and I want to count how many points are within some total distance. I do the min and the max. I think I got that right, got that right, got that right. I compute a delta. And so let me just think about that. So again, let me return this. And let me run this. So let me think about this for a second. Okay. So now what I said was that for x in range 40, 347, for y in range, and this, yeah, 53, 352. Print x comma y comma point xy dot total Manhattan distance point for points. So let's think about this. Int object has no attribute x. Why is that? Because I did this totally wrong. Total Manhattan distance. I'm trying to do the sum when I already had the sum. So let's just get rid of that. And so if I look at the 346, everyone's well above and so let's just print these. So let's change this and say for x in 40, 347, and for y in 53, 352. So those are all way too big, and they're going to only get bigger. So let me just try this outside of here. For that, if point dot xy total distance points is less than 10,000, count plus equals 1. Except that I didn't want to do that. I wanted to do range. .46054, and I think that's what I guessed, and it was not right. So maybe I'm approaching the, maybe I've got the problem wrong. So let's read it again. If the coordinates are safe, each location add up the distances to all the given coordinates. If the total of those distances is less than 32, regions within the desired region. Using the same coordinate as above, the resulting region looks like this. Here consider 4, 3. It's distance coordinate A is 5, distance coordinate B is blah, blah, blah. Because the total distance to all coordinates is less than 32, it's within the region. This region, which also contains coordinates D and E, size of the region containing all locations which have a total distance to all given coordinates of less than 10,000. So I got this test case right, but I got the bigger test case wrong. Size of the region containing all locations of a total distance of all given coordinates of less than 10,000. So let me reread the problem. Maybe I've got coordinates or points or something wrong. Only Manhattan distance during the distant area around each coordinate by counting the number of integer xy locations that are closest to that coordinate are tied in distance. Large area is infinite, blah, blah, blah. That's fine. If the coordinates are safe, maybe the best you can do is try and find a region near as many coordinates as possible. For example, suppose you want the sum of the Manhattan distance to all the coordinates to be less than 32. For each location, add up the distances to all the given coordinates. The total of those distances is less than 32. That location is within the desired region. Take care, consider the highlighted location 4, 3. Calculation as follows. Okay. So the total distance is less than 32. The location is in the region. This region, which also includes coordinates D and E, which has nothing to do with anything, total size of 16. Your actual region is being much larger. It's including all locations with a total distance of less than 1,000. What is the size of the region containing all locations have a total distance to all given coordinates less than 1,000? So if I use the test set, let's go back and check this out. And it should give me I don't know what that did. It gave me 1819, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let me look at theirs. So for instance, you know, they have 4, 3 is one of theirs, and we have 4, 3. 4 point in points, print point, comma, actually no, let's just print point dot Manhattan distance to point 4, 3. And so let's check these out. So that says 5, 6, 4, 2, 3, 10. And if I look at theirs, they say 5, 6, 4, 2, 3, 10. So here I'm doing exactly the right thing. And so the question is, why am I not doing it here? Is it possible that I screwed up? No, it's not possible because that gives me the points. I've got all the points. Points, len points. There's 50 of them. And now sorted p.x for x in points for p in points. Okay, so goes from 40 to 346. X goes 40 to 346. Sorted p.y for p in points. Y goes from 53 to 351. And so, you know, let's do, if I start at point 40, 53, so that's top left, dot total Manhattan distance points, that's 15,000, so that's too big. Point 41, 53, dot total Manhattan distance points, that's less. So let me do a couple of these over here, just messing around. For x in 4x in 43, 46, 4y in range 53, 352, print xy point xy total Manhattan distance points, and then similarly 4y in 53, 352, 4x in range 40, 347, and again that. So let's see what it looks like on the boundary over here. So basically this is saying there's nowhere on the boundary that that's less than 10,000. So in particular, once you go past the boundary, it's really not going to be less than 10,000. So you know, print len x, I'll do that. So just in grid equals xy for x in range 43, 47, for y in range 53, 352. If point x comma y dot total Manhattan distance points. Actually, you know what? Let's do point x comma y dot total Manhattan distance points. So let's do that. Len p for p in grid if p minus 1 is less than 10,000. Right, that's not valid syntax. 46054. All right. I'm keeping popping over here to see if anyone knows what I'm doing wrong. Because let's look at the leaderboard, and first 100 users get both stars. So a bunch of people already have. So clearly they're seeing something that I'm not seeing. Dangerous, minimize danger, find the coordinates of the largest distance. Largest area that is infinite. Okay. If the coordinates are safe, maybe the best you can do is try and find a region near. Holy cow. How long have I been doing this for? 54 minutes. Okay, that's not good. If the total of those distances is less than 32, the location is within the desired region. Using the same coordinates above, the region looks like this. including all locations with a total distance of less than 10,000. What is the size of the region containing all locations which have a total distance of less than 10,000? So it's clear that I've done something wrong. So let me do min of, actually I did, it is a triple, so let me do that. So 78 is the smallest, and 86 is the smallest y, and 312 and 334, 312, 334, all locations with a total distance of less than 10,000. What is the size of the region containing all locations which have a total distance to all given coordinates of less than 10,000? So four 46054, and that was my wrong input. Okay. So I have a bunch of points, some total distance. I find the min x, the max x, the min y, the max y. And then I go out an extra distance, and I compute the total Manhattan distance to all the points. So let me make sure that function is right. That function looks right. And if that's less than the total distance I want, I add that thing to my squares. So let's run it again. Did I put an earlier return in there? I did not. Print xy tmd. And let's look up one of these. 311, 196. So 0.311, 196. Total Manhattan distance points is 9921. Okay, so for P and points, D's equals P dot Manhattan distance. Let's do this. 311, 196 dot Manhattan distance, P for P in points, and let's keep P as well, so I can inspect these. So I want to go to 311, 196. So the closest is 196, 237 is 41, plus 1 is 42, so that seems right. And 311 to 196, so that's 130 plus 12 is 142. That's 81 plus 43, which is 124. So these all look right. 50 points. Let's make sure that that's the right number. Let's start these points and see if there's anything unusual about them. Am I reading them wrong? Distance to all coordinates is location within the region. This region, which also contains coordinates D and E, has a total size of 16, including all locations with a total distance of less than 10,000. What is the size of the region containing all locations which have a total distance to all given coordinates of less than 10,000? So, squares, no, that didn't do anything. That was what I did. I think that was what I did last time. That's not the right answer. Your answer is too high. That's for hints on the subreddit. So other people are having problems too. 46054 for what it's worth. That's what I put in, right? 46054. You know, yeah, yeah, maybe it's a bug there. I can't figure out what I'm doing wrong. I'm going to call it. So thanks. Thanks for watching, and yeah, that's kind of frustrating, but it is what it is. So